Good day everyone, you're welcome to my YouTube channel today. Today is the beginning of this lecture on introduction of the gamma function. Now, the first question I need to ask here is, have you ever seen a function involving a constant looking so beautiful and easy? The answer to this question is yes. And what is that function? That function is the gamma function. The gamma function is the extension of the factorial, which is defined as, the gamma function is defined as, this is the symbol here, the gamma of x is equal to integral as x goes from 0 to infinity e raised to power negative t times t raised to power x minus 1 dt. Okay, so this is the integral representation of this beautiful function, and this integral converges for all x to be greater than 0. So what does this actually mean? This actually means that if x is exactly equal to 0, then this integral, the whole integral, will diverge. But if x is less than 0, it will also diverge. When x is greater than 0, as stated here, the integral converges. Okay? Now, why do we say that this is the extension of the factorial? Okay? Now, the gamma of x plus 1, okay, is equal to x plus 1 minus 1 factorial, and this is giving us the x factorial here, like this. Okay, so that means that is the gamma of x plus 1 is equal to x factorial. Okay, now we are going to some properties of this function. So the property we're going to prove here is that the gamma of n plus 1 is also equal to n times the gamma of n. Okay, now how do we prove this? Let's see how we're going to prove this property here. Okay, now let's take a note that the gamma of n, okay, is equal to integral as s is going from 0 to infinity, okay, e raised to power negative x times x raised to power n minus 1 dx. Okay, we already know that this is the integral representation of this function. Okay, now this n, we are about to prove this, so we need to have this at the left hand side of this equation here. So let's replace this n by n plus 1. So what are we having? So we're having the gamma of n plus 1 is equal to integral as s is going from 0 to infinity, okay, e raised to power negative x times x raised to power, instead of writing this n here, so we write n plus 1 then minus 1 dx, and this simplifies here. So this simplifies here to integral as s goes from 0 to infinity e raised to power negative x times x raised to power n dx. Okay, now we're going to start integrating this by parts. So we're going to start integrating this by parts. So how do we do this? Now we need to know this theorem of integration by parts. So let's start by saying let u equal to this x raised to power n. Okay, that is this x raised to power n here. Now we all know that the u is going to be to multiply and subtract 1 from the exponent. So we have n times x raised to power n minus 1. Okay, now we're going to do another substitution according to the theorem. So let v equal to this, the integral of e raised to power negative x here is going to give us the negative e raised to power negative x. So now when we differentiate this, mind you that when we differentiate this v here, so we must get this e raised to power negative x here. Okay, now we have dv is equal to e raised to power negative x dx. Okay, I forgot to put this dx here. Now, according to the theorem, we have the theorem, integration by parts, that this will be the same as u times v minus integral of v du. Okay, now we're going to apply this theorem here. So now what do we have next? We're having gamma of n plus 1 equal to uv. So uv is x raised to power n times negative e raised to power negative s. So let's factor out negative sign first, then x raised to power n times e raised to power negative x. So remember that this x is going from 0 to infinity, then minus, according to this theorem here, so integral of v, that is the integral of this here, so this is v, so integral of v from 0 to infinity, negative e raised to power negative x. Okay, now times du. So where is our du here? So this is our du here, n, that is n times x raised to power n minus 1 dx. So n times x raised to power n minus 1 dx. Okay, now this is simplifying to, now when we the limit as x is approaching 0 here, we all know that this whole expression here becomes 0, and limit as s is approaching this infinity here, remember that this is negative power of infinity here. So now this is approaching 0 as well. Now this whole thing here is what? 0, according to this boundary here. Now remember that we have this negative sign here and we have a negative sign, so this changed to plus here. So now we have to factor out this n here, take it out of this integral sign. So we have n times integral from 0 to infinity, okay, e raised to power negative x times x raised to power n minus 1 dx. Okay, now we are very familiar with this here, so we all know that this here is the gamma of n. So this is the gamma of n if you watch exactly from here. So e raised to power negative s times s raised to power n minus 1, which is the gamma of n, and here we have e raised to power negative s times x raised to power n minus 1, so that is the gamma of n. So we have now that the gamma of n plus 1 is equal to n, as you can see it here, n times the gamma of n here. So we have proven the theorem here. So now what is the next thing to do? So let us learn more of the properties of the gamma function. Okay, so let us learn more of the properties of the gamma function. So we also have that, as we have gotten that the gamma of n plus 1 is equal to n times the gamma of n. Okay, now we also have another property, very nice, that the gamma of 1 all over 2 is equal to square root of pi. Okay, we don't need to forget this, so always bear this one at the back of your mind, that the gamma of 1 all over 2 is square root of pi. Okay, now we have the Euler reflection property, one of the greatest mathematicians, the Euler reflection property, which is giving us the gamma of 1 minus m, okay, times the gamma of m is equal to pi all over sine of pi m. Okay, and this exists when 0 is less than m and m is less than 1. Okay, now we also have the duplication formula. So the duplication formula is gamma of m, okay, times the gamma of m plus 1 all over 2 is equal to 2 raised to power 1 minus 2m, okay, times square root of pi times the gamma of 2m, okay. So this is the duplication formula. Now we have entered into the main lecture here, okay. Now we're going to see the application of this gamma function, okay. So we are starting with, so let's write application in solving problems. So application, now we are going to evaluate this integral here. Integral as s is going from 0 to infinity, okay, x raised to power 2 times e raised to power negative 2x dx, okay. Now we're going to evaluate this. So let's see how we're going to evaluate this now. Now let's say I is equal to integral as s is going from 0 to infinity, okay, x squared times e raised to power negative 2x dx. So, and this is what we are about to evaluate, okay. Now we're going to make a substitution. Now before you start solving this problem, always record that the gamma of n is equal to integral as s is going from 0 to infinity e raised to power negative x times x raised to power n minus 1 dx, okay. If you check the power of e here, it is only negative x, so the coefficient of x here is negative 1, and here we're having negative 2, so it's not corresponding with what we are seeing here. So we need to make a substitution here. So what is that substitution? So we can say let this 2x equal to y, okay. Now we say let 2x equal to y. Now when we do this, divide both sides by 2, we get x is equal to y over 2. Now differentiate both sides, so we have dx is equal to dy all over 2, okay. Now this I becomes integral as x is going from 0 to infinity. Remember that 2 times, like to check the new boundaries here, when x is equal to 0, when s is equal to 0, we have 2 times 0, 2 times 0, that is 0. When s is equal to infinity, 2 times infinity is infinity, as x is approaching infinity here. So now our x squared here, this our x squared here. So what is it going to be? So remember s is equal to y all over 2 here. So if you square both sides, so we get our s squared to be y over 2 raised to power 2, okay. Now times e raised to power minus y. Now what is our dx? So we're going to make a substitution of this dx. So our dx here, as you can see it here, is equal to dy all over 2. So we put dy all over 2 here, okay. Now we're going to do some simplifications here. So our I is becoming, so now we have integral from 0 to infinity y squared over 2 squared here is 4 times e raised to power negative y, okay, times dy all over 2. So this is what we have next here. Now this 4 times this 2 here is 8, so that is 1 all over 8. Take it out, so we have this to be 1 over 8, okay. The integral as s is going from 0, as y is going from 0 to infinity, then y raised to power 2 times e raised to power y, e raised to power negative y dy. Now these two, remember this function here, that the power of x must be we must subtract 1 from it, so it must look exactly like this. That is the power of s. So now here we have only 2 here, so these 2 here, we're going to rewrite these 2 as what? 3 minus 1. So it will look somehow like this. So we're going to rewrite these 2 here as what? 3 minus 1. So, and when we do this, now when we do this, we have I equal to 1 over 8 integral as x goes from 0 to infinity, okay, y raised to power 3 minus 1, then times e raised to power negative y dy. So, when looking at this, so this is the gamma of 3. If this here, if this gamma of n is like this, so x raised to power n minus 1, and we have y raised to power 3 minus 1, so this is the gamma of 3. So we have this as 1 over 8 times the gamma of 3. So now, how do we evaluate the gamma of 3? How do we evaluate the gamma of 3? Remember that the gamma of n plus 1 is equal to n factorial, okay? Now, the gamma of 3 is equal to the gamma of 2 plus 1, okay? And this is equal to 2 factorial, and 2 factorial is equal to 2. 2 factorial is equal to 2. So what do we have next here? So we have this to be 2 factorial over 8, and that is equal to what? 2 over 8, giving us what? 1 all over 4. So what do we have to say now? So we can say that the integral as x goes from 0 to infinity of x raised to power 2 times e raised to power negative 2x dx is equal to what? 1 all over 4 with the help of this gamma function. Now, thank you for viewing, and I'm going to drop a question here. So if you can solve it properly, drop your answer at the comment section. Okay? So evaluate using this gamma function to check your understanding. The integral as x goes from 0 to infinity. So let me say x raised to power 3 times e raised to power negative 4x dx. So if you can solve this very well according to this tutorial, drop your answer at the comment section and I will reply you. Thank you for viewing. If you enjoyed this lecture, please subscribe. Remember to subscribe and share this video so that others will gain a lot from it. Thank you once again.